Graphing Quadratic Functions by Jared Scott, Chloe Lawton, and Jessica Southern.
This is our A term, which is our quadratic term. This is our B term, which is our linear. C is our constant. The graph of a quadratic function is called a parabola.
Here's our example problem up at the top. Notice term A, B, and C. So how do you know if the graph will open up or down? If the A term is positive, the graph will open up. If the A term is negative, the graph will open down. So look at the A term in our example problem. Notice it is positive, therefore our graph of the parabola will open up.
How to determine a maximum or minimum? A parabola that opens up will have a minimum point. A parabola that opens down will have a maximum point. We determined that the graph will open up. That means that our graph will have a minimum point.
How to determine the axis of symmetry. Again, here's our example problem with term A, B, and C. The equation of the axis of symmetry is x equals negative b over 2a. When we plug in our numbers from our equation above, we find that the axis of symmetry equals 3.
How to find the coordinate of the vertex. To find the x-coordinate of the vertex, use the formula negative b over 2a. Work out your problem and you got 3. Then plug in x in the original problem to find y. Work it out and get 3, negative 12.
As your vertex. Graph the function. First create an xy chart. You're going to place your vertex coordinates in the middle of the chart like we did here. Notice our vertex, 3, negative 12. Then you're going to plug in x values in the equation to find y. Graph your points and connect the points on your parabola. So we notice that our graph opens up and it has a minimum point that matches all of our data.
The End by Jared Scott, Chloe Lawton, and Jessica Southern.